Good afternoon, everyone. My name is Marco, and I'm a chemist. And I'd like to start this presentation with a short story. In 1880, a revolution started in the United States when a gentleman called Thomas Edison, you might have heard of him, in his laboratory produced the first long-lasting modern light bulb. And nothing could be the same ever again for any of us. Because now in 2015, electricity and light bulbs are everywhere. And being in the lucky 82% of the world population with easy access to electricity makes it hard for us to imagine how we would live without it. How would we communicate, power our appliances and devices, or even store our food? Many, even in this university, are finding everyday new ways to harvest the power we need to sustain our lifestyle, from sun or wind. And thanks to them, today, the total power generation worldwide is increasing. But here's the challenge: how we distribute this excess we have created with the infrastructure we have. Take the UK National Electric Grid as an example. It was built in the 60s. How many of us own electrical appliances from the 60s that still work fine? But remarkably, still a valid way to move loads of power across the country using high voltage transmission lines. But high voltage alone is not enough, because we can't really plug our smartphones to high voltage. We'd fry them, and that's no good. So what we need is something that changes and tunes the voltage to our everyday needs. And this something is a transformer, a power transformer. And my job is about taking care of them. Because they contain copper, that to do its job needs to be immersed in insulating fluids, such as oils. Unfortunately, some of this oil may contain reactive sulfur species or impurities that are able to attack and corrode the metal within them, causing their failure and then blackouts with huge economical and material damage for everyone. Luckily, chemistry created some compounds, like our superhero up there, that is patrolling the UK transformer fleet as we speak on behalf of National Grid, and is standing bravely between our houses and ourselves and the next blackout. This kind of molecule is a very long and complicated name that is definitely not fit for the superhero it is. So we just call him a passivator, because it's able to form a protective layer or a passivation layer on the surface of a metal to prevent its corrosion. And studying this passivation layer in detail is the subject of my PhD. And so far, looking at it by means of advanced chemical techniques that use X-rays and ion beams, I already discovered how much passivator is really needed inside a transformer, the negative effect of certain oil impurities on its stability, and I also exposed its limitation in working at high temperatures. And this kind of knowledge is fundamental for the correct maintenance of our aging electric grids worldwide and to ensure the reliable power supply the world needs for the future, so that we never come to regret the time when Edison light bulbs were just a flip of a switch away. Thank you very much for listening.